Hello, I am going to go through a worksheet called Calculating Molar Mass with you. I will go ahead and get there. So this worksheet is not a grade, but I think it will help you when we move on to converting moles to mass and mass to moles. So what we're going to do, let's talk about the principle of this first. So a mole, remember, is kind of like a chemist's dozen. It represents the number 602 hexillion, or 6.02 times 10 to the 23rd power. So that means that I can have a mole of jelly beans, I can have a mole of people, I can have a mole of donuts, right? But in chemistry, we use it to talk about the number of atoms or molecules that are present in a given quantity. So what we're going to do here is we are going to pretend that we have 1 mole of each of these molecules. So I have, for instance, 602 hexillion of these molecules, or I have 602 hexillion of these molecules, or these, all right? So what we're going to do is we're going to take their atomic masses from the periodic table, all right? I'm not just pulling these numbers out of nowhere. These numbers are given to you on the periodic table. We know that the atomic mass is calculated knowing the number of protons and neutrons in a given element. But we can also use this number to convert easily from mass to moles, because the atomic mass is the exact same as the molar mass. We just express it in grams instead of atomic mass units. So what that means is that for every, let's just give, let's use carbon, for example. For every carbon atom, if I have a mole of carbon atoms, which means I have 602 hexillion carbon atoms. And that means that based on carbon's atomic mass, which is 12.01, that means that a mole of carbon atoms will weigh 12.01 grams, okay? So we're not talking about atomic mass units, we're talking about that same number, but expressed in grams instead of atomic mass units. So let's take that information and apply it to these molecules. This is a lot simpler than it sounds like it's going to be. So what we're going to do is we're going to find the atomic mass, or the molar mass, of each of these elements. We get that from the periodic table, and then we're just going to add them together. The only difference being that if there's a subscript in a molecule, then that just means you multiply the atomic mass, or the molar mass, times the subscript. So for instance, hydrogen's atomic mass, or molar mass, we're talking specifically about molar mass, is 1.008. Because it's molar mass, we're using grams. Let's do that first. Second one is nitrogen. Looking on the periodic table, the molar mass of nitrogen is 14.01 grams. Right? A number by itself is meaningless. We always have to have a unit with it. Because it's molar mass, we're talking in grams. If we were talking atomic mass, we would be using AMU, atomic mass units, or just the letter U. Oxygen, according to the periodic table, has a molar mass of 16.00 grams. So for 602 hexillion oxygen atoms, that would weigh 16 grams. So what I'm going to do is just multiply these together. And I'm not actually going to do that right now. So I would take 16 times 3, which is 48, and add that to 14.01 and add that to 1.08. So if we do rough math, 48 plus 14 is 62 plus 1. So it's roughly 63 grams, right? So 1 mole, 602 hexillion of these molecules will weigh roughly 63 grams. Let's do another one. Potassium, its molar mass is 39.10 grams. And chlorine's molar mass is 34.45 grams. All we have to do is add those together. There's no subscripts. So let's round it to 40 plus 35, roughly 75 grams per mole. So every 602 hexillion potassium chloride molecules, it weighs about 75 grams, right? So let's do this next one. Barium has a molar mass of 137.3 grams. So this is a much heavier atom. Carbon's molar mass is 12.01 grams. And oxygen's, again, is 16.00 grams. So we just do some math. 16 times 3 is 48, plus 12, roughly 60, plus 137. So we're looking around 197 grams. All right, so if I have 602 hexillion of these molecules, it's going to weigh roughly 197 grams. All right, so you just do that for all of these. Let's go ahead and go down to this one because it's a little different. So first we have beryllium, right? So when you see a subscript outside of parentheses, it means that subscript applies to everything inside the parentheses, not anything before it. So the beryllium has an imaginary subscript of 1. So what I'm going to do, we don't need to multiply it by anything because they're just one of them. So the molar mass of beryllium is 9.01 grams. All right, the molar mass of nitrogen, so that's the next one, is 14.01 grams. All right, and then we also have the molar mass of oxygen as 16.00 grams. And then, because of order of operations, first we multiply the 16 times 3, which is 48, plus the 14 from the nitrogen, so 48 plus 14 is 62. And then you multiply 62 times 2 because of these brackets right here. So 62 times 2 is 124, plus 9 is 133, roughly 133 grams. So if I have 602 hexillion of these molecules, that's going to weigh roughly 133 grams. So this is a pretty simple concept. Just wanted to cover it and make sure you guys are 100% on this before we move to mole mass conversions.